This is Mission Control Houston, now watching video that was recorded by the crew on board Atlantis of the external tank after it fell away from the orbiter after main engine cutoff. This video is being downlinked to Mission Control, so imagery analysts and engineering experts can review it and assess the foam coverage on the external tank. This all added to a compilation of imagery and data that helps the experts determine the integrity of Atlantis's heat shield, the thermal protection system that is in place to protect the orbiter when it enters into the Earth's atmosphere again at the end of the mission.
This is a view of the left-hand payload bay door coming open. In the foreground, the P3, P4 truss element, the main focus of Atlantis' mission to deliver that 35,000-pound truss structure to the International Space Station. Also in the center portion, the shoulder joint of the shuttle's remote manipulator system, the robotic arm, that will see an extensive amount of work throughout this mission. The first part of its operation will be a little bit later today when it's checked out before the crew goes to bed in preparation for tomorrow's extensive investigation and inspection of the shuttle's wing leading edge panels.
Space Shuttle Atlantis currently orbiting 212 statute miles over Europe, catching up with the International Space Station with docking scheduled for early Monday morning. This is Mission Control Houston with a live view from the camera on the shuttle robotic arm during the survey, looking at the starboard side of Atlantis. The live video is expected to be intermittent, but the crew is recording this entire survey on board for downlink if necessary. The jets of the on the nose for the reaction control system are visible here. Part of the procedure of the survey at the beginning is to inhibit those jets from firing, as the shuttle arm will be so close to the jets. With the starboard survey complete, the crew moving the robotic arm so that the end effector camera can be trained on the port side of the upper surface of the orbiter. As the shuttle robotic arm is being maneuvered, this camera providing a nice view of the starboard payload bay door open, exposing the radiator to expel heat from the orbiter. The robotic arm now crossing over Atlantis' payload bay with the P3, P4 truss structure, the 35,000-pound truss on its way to be installed on the outboard port side of the International Space Station to add another set of solar array wings that provide a power generation capability by collecting the sunlight and powering equipment on the station. This survey, when it is complete, will end the inspections of the thermal protection system for today, with all the information being sent down to Mission Control for engineers to analyze and to confirm the integrity of Atlantis' heat shield. The crew will also work on setting up for rendezvous and docking to the International Space Station. The remaining tasks for today to prep for that docking tomorrow include installing the centerline camera that is scheduled to be done by Commander Brent Jett and Mission Specialist Joe Tanner. That camera will provide Jett straight-on view to the docking mechanism at the International Space Station tomorrow. After installing the centerline camera, Tanner and Mission Specialist Steve McLean scheduled to install the orbiter docking system, actually extending the ring of the orbiter docking system that will make contact with the station and secure the two vehicles together.
And Atlantis, we're on board. We have some good video. Thanks. We're waving back.
Houston, we're on the orbit, Ohms burn, 2 card. Atlantis, we copy.
Just under 4 minutes now to the NC4, the next rendezvous burn, looking over the shoulder of Brent Jet, monitoring the cue card, as he calls it, that cue card referencing the details that are loaded into the onboard computers in front of him. The displays showing the details for this burn. Again, a 11-point-second change in velocity, lasting 15 seconds using the reaction control system jets on the shuttle Atlantis, currently in a 181 by 176 nautical mile orbit. The result of this burn will put Atlantis in a 183 by 181 nautical mile orbit. That's about 210 by 208 statute miles. Pilot Chris Ferguson, as small pulses to the thruster jets underway to refine the orbit. Atlantis's range is 40,800 feet. External cameras on the International Space Station being maneuvered to try to capture a view of Atlantis at that distance, with the terminal initiation burn clock counting backward a little more than 9 minutes to the TI burn. Standing by for the terminal initiation burn. Again, this burn coming at a range of about 44,000 feet behind the International Space Station.
Atlantis Station on the big loop. Good morning.
Hey, Jeff, good morning. We got a tally ho on you, and we're currently about 26,000 feet, just about 10 minutes from our MC2 burn.
Very good. Yeah, we've got a good view of you as well. You're looking good. See you soon.
Space Shuttle Atlantis from 2,300 feet from the International Space Station, closing in at a rate of 3.5 feet per second. Standing by for the final mid-course correction burn. That burn upcoming about 1 minute from now. A 7-second firing, changing the velocity by 1.5 feet per second, or about 1.1 miles per hour.
Yeah, Houston and station, we're about 5 minutes from the RPM start. Good HHL correlation.
$220 miles above northeastern Africa. The rotational pitch maneuver underway as the International Space Station crew, Expedition 13, basically has the same view, using high-powered long-range lenses to document the thermal protection system.
You can start photos.
Approaching the northwest coast of Algeria, traveling northeasterly, just about to cross the coastline, heading out across the Mediterranean. Atlantis 2/3 of the way through the rotational pitch maneuver. Beautiful view of Space Shuttle Atlantis from the International Space Station at a range of 600 feet. The 45-foot-long P3, P4 truss in Atlantis' payload bay, headed for its final home at the International Space Station as the two spacecraft approach the coastline of Italy from the southwest. And the coastline of Italy below Atlantis, with the space station 600 feet above the orbiter. Inside the International Space Station, Jeff Williams and the rest of the Expedition 13 crew awaiting the arrival of Atlantis. The orbiter is inside 200 feet now at 189 feet, continuing to close at a very slow 1/10 of a foot per second under command of Brent Jett at the aft flight station, looking out the overhead windows of Atlantis.
Houston, station capture confirmed.
And station is in free drift.
Atlantis, Houston, station free drift confirmed.
At 5:48 a.m. Central Time, mission elapsed time of 19 hours 34 minutes. Into the third flight day of the mission, Atlantis has arrived at the orbital outpost.
Station Houston on the big loop. We see your visitors. Give us a wave.
You in the lab camera or the node camera, or both?
Node camera.
The shuttle's remote manipulator system, Canadarm, is firmly grappled the P3, P4 truss element. And a little bit later this morning, the crew will execute procedures to unlatch that payload from the payload bay of Atlantis.
This is Mission Control Houston, continuing to watch video of the truss structure being removed from the payload bay of Atlantis as the International Space Station in Space Shuttle orbit about 211 statute miles over the Gulf of Mexico. As the robotic arm operations continue to hand off the P3, P4 truss structure, station astronaut Tomas Ryder and shuttle astronaut Joe Tanner setting up equipment for the pre-breathe procedure tonight in the campout that Tanner and Piper will be participating in. Station astronaut Ryder helping with that procedure. He's very familiar with the Quest airlock and spacewalking procedures, having helped with the spacewalks during the STS-121 mission, and he conducted a spacewalk himself with Williams at the beginning of August from that Quest airlock.
Station Houston on Space to Ground 2, just an advisory and a reminder. While we are both grappled to P3, P4, which will be in just a moment here, there is no exercise on station.
Roger, understand.
As the space station robotic arm will be moving in to grapple the truss structure, astronaut Pam Melroy reminds the crews on board that this will be a moment when no exercise can be conducted on board the complex to minimize any disturbances between the two vehicles until the shuttle robotic arm lets go with the truss in the firm grasp of the station robotic arm.
And Houston, station P3, P4 is grappled, and there you have it, the great Canadian handshake.
Houston copies, well done.
We're looking in the space station's Quest airlock now with astronauts Joe Tanner and Heidi Marie Stephanician Piper with the oxygen masks on, preparing for their spacewalk tomorrow. This is part of a special pre-breathe procedure to breathe pure oxygen and then stay in the Quest airlock with the pressure reduced down to 10.2 pounds per square inch while they sleep. They won't be wearing the masks overnight, but then in the morning, They'll put the mask back on and open the hatch again after repressurizing it back to 14.7 pounds per square inch so that the rest of the crew members can help them prepare for the spacewalk. And this entire procedure helps purge their system of nitrogen to minimize the chances of any effects of decompression sickness, or more commonly known as the bends, while they wear their low-pressure spacesuits during the spacewalk on Tuesday.
This is a truss segment that will be installed on the port side, thus the designation of P3 or P4 for port. The P3, P4 truss under control of the station robotic arm on its way to the pre-installation position, having been in a park position overnight. This will place the truss segment in the proper orientation for installation.
Houston, station for EVA on 2.
Go ahead, Brent.
Hey, Kevin, we're ready to start EMU donning. However, we're a little concerned we might be a little bit in front of the robotics. If we start now, we estimate we'll be throwing helmets on in under 30 minutes or so. So we wanted to get your take. We should start EMU donning or not.
Okay, let us coordinate it just a second.
Houston station for robotics. Brakes are off. We're in mode, and we're pushing into 30 centimeters.
We copy that, Steve, and we're ready.
On board the Destiny laboratory of the International Space Station, as Steve McLean at the robotic workstation. To his left shoulder is flight engineer for Expedition 13, Jeff Williams. Steve McLean now will be maneuvering the P3, P4 truss element into about 30 centimeters. That'll be the next stopping point on the way to the permanent attachment of P3 to P1. One of the capture latch assemblies on the element clearly visible, looks similar to a claw. Once the ready to latch indicators are all go green on the displays, those capture latch assemblies will be activated.
Houston station for EVA, step 68 of camp out prep.
Once the initial contact is made with the 3 ready to latch indicators, a signal will actually be sent that provides the indication to the crew on board that the capture latches are ready to be closed. Each one of those ready to latch sensors actually contains dual redundant micro switches. Only one of the switch indications is required to proceed with the actual capture latch actuation.
Okay, Dan, in that case, that completes the EVA-1 inhibit pad.
Joe Tanner in the right portion of the picture, Heidi Piper over on the left side of the view, working on 2 different truss segments.
The aft beta gimbal restraints, remove the 2 pit pins.
Copy that, Heidi. P6 is released. Okay, copy. The next is to mate P5 to J5. All of the accompanying steps.
Joe Tanner releasing cables. The P6 cable is a high rate data link cable. He's also now ready to relocate another cable, which is another data cable. In the meantime, Heidi Piper is working on releasing launch restraints for the new solar array blanket boxes, and also the beta gimbal assembly restraints holding that in place.
P3 to J3 is complete. Good connectivity. Okay, copy that. Now you're going to demate P2. These things are a lot harder than the ones in the water.
pretty stiff, no doubt.
Yeah. P2's demated.
Okay, now demate P1.
Okay, Dan, multipliers in place. Backlash was verified neutral. Yep. And Bravo 7, counterclockwise 3.
Good settings.
P1 is demated.
Okay, now you can mate P2 to J2.
Joe Tanner now having connected the data cables is now in the process of connecting the power cables between the P1 and or P3 and P1 truss elements.
I wasn't even touching it. Release of a rep.
Okay, got black on black. Good pull check.
Okay, copy that.
High above South Central Asia. Heidi Piper at the bottom of the screen, Joe Tanner in the center of the picture.
Okay then, yaw of 11. Echo, yaw of 11, correct?
For the inboards, we'll take a yaw of 12.
Okay, so I got 12. Okay, there it goes. Give it a little push.
Might stop half travel again.
Okay, I'm going to give it more of a push.
The shuttle and station complex approaching an orbital sunrise and the west coast of Chile as it travels northeasterly across the eastern Pacific Ocean. The first of the two solar array beta gimbal assemblies deployed, and the second is in work.
Slow down a little bit, Eddie.
Okay.
A little slower. Okay, that's good.
And as I mentioned to Joe too, you've got the limitation on the rotation rate, of course, and also the pinch point consideration.
Okay, the sleeves did engage. I'm going back to put the pit pin in.
Okay, copy that.
Okay, pit pin is reinstalled. You see that?
Yes, I do. Thank you. Same thing for the other wing.
And did you get the same thing for the locking collar?
Actually, I blanked just then. If you wouldn't mind, give me another quick view of that.
Okay, I want to get the pit pin first.
Heidi Piper out on the end of the mast canister, deploying the solar array wings, the canisters that hold each panel of the solar array wing.
There's the locking collar.
Okay, I got a great view. Thank you, Eddie.
Okay, here comes the other one. And I'll go nice and slow.
Brake torque on the inboard was 2.3, and that would be 1 Bravo.
Copy that. Bolt 1 Bravo, broke torque at 2.3.
Yeah, you don't care about that. It's just information.
It's just
Heidi Piper serving as a wonderful reference tool regarding the size of this pair of solar arrays that are housed inside these twin canisters that will be deployed in a couple of days.
1 Bravo, 2 Bravo.
2 Bravo.
They're both released anyway.
Okay, Dan, there's the
Atlantis, Houston, for the big picture on EVA.
Go ahead, Pam.
Okay, just to let you know, we're hoping to get a go for the 4A shroud here shortly, but since Heidi and Joe have done such a wonderful job and are really ahead in the EVA, we'd like to brings some tasks forward from EVA 2. So if you'll open up the page to 7-45, I can talk you through what we're going to do.
Boy, John's been having fun. Cover is removed. Launch block 7 is exposed.
Copy, Joe.
Oh, how about that? What's that? One of the Fairchilds came apart. Which one? So we're going to be down to, I just caught the washer from it. The bolt disappeared. Okay, I'll have to tell you in a second which one it was. Alpha, the lower left, that's Alpha 1.
That was an inboard bolt, Alpha 1?
Yeah, an inboard bolt, not a good thing.
One of the bolts has come off. It's, if you look at 7-29.
Okay, Steve, covers 17 and 16 are removed, and so the only ones left are on 15.
I'm there.
Okay, copy that.
It's A1.
I lost the washer too, but it's going away.
Okay.
And he'll have to use the remaining inboard bolts to reinstall the cover.
This was an inboard bolt. That's what I heard him say.
Yes, it's an inboard bolt.
Okay.
Houston Alpha, it looks like we have lost the bolt and perhaps the spring in the washer on Alpha 1. It looks like we have.
Houston, or Atlantis, Houston, we copy, and we'd just like to get confirmation from Joe about what direction he saw that bolt depart, or the washer, or any other information.
Well, that's the problem. The washer is gone. It went in a good direction forward. The bolt and spring stayed together. I only got a glimpse of it, but it departed pretty much zenith, but not directly at C6. Of course, it could have ricocheted off of anything between me and the zenith corner.
Does he think it went into the structure or out?
And Atlantis, Houston, the question would be, did it go into structure or away from structure?
Well, it was grazing across the surface of structure. And it would have been across cover 19 and 18, and probably in between cover 18 and the that launch restraint 5.
Truth to tell?
Piper Scene here in this live view of the truss structure, reporting that the launch lock number 2 is removed. The one launch lock she is removing in advance that was scheduled to be removed during tomorrow's spacewalk.
Clockwise 2 to install.
Oh, that's right. Clockwise 2, and you've got 8 turns.
That'll lock that secured the rotary joint during launch.
And we have good video, Heidi.
Okay. If you're happy with that, I'll put the cover back on.
Okay, great. Verified.
Steve McLean already replacing the cover over the location from which he removed launch lock number 5. In the meantime, this view up close and personal with Dan Burbank as he removes the loosens the bolts, protecting the or holding the launch lock number 16 in place.
Okay. Green torque.
a very good inspection of the solar array rotary joint, the launch lock removed.
Okay, 4 bolts are intro.
Copy. That lock is going in bag 2 also.
That's right. And I'll take it right after I'm done. Here.
Steve McLean now at his third work site to remove cover 17 to provide access to launch lock number 4. And as we saw through the helmet cam of Dan Burbank, he is at his work site for cover 10 removal.
Okay, Heidi, on cover 10, feathers are in place. For the inboards, Alpha 6, counterclockwise 3.
And Dan, that's a good copy.
Okay, on cover 8, a bolt is missing. Bolt 1 alpha. I did not see it go.
Okay, Steve, I copy that bolt 1 alpha is missing.
And that's the bolt where the 2 tethers were.
And Steve, I don't know if you can add any comments as to when you noticed the washer missing. Was it when you pulled the
I
bolt?
did not see it go. I did not see the bolt go, so I don't know when that happened.
Okay, so it wasn't like when you put it down that you noticed one of them missing or anything like that?
Right, that's correct. I pulled the launch cover off. All 4 bolts were there. And then when I went to put it back on, I had 3 of them tacked. Went to tack the 4th one underneath the 2 tethers, and it was not there.
Okay, thanks, Steve. I just wanted to get a little more information or give that to the ground.
Okay, and I'm looking inside the whole structure here, trying to see if there's anything floating. It may have come off when the cover was away from the structure. So nothing is catching my light inside the structure. Nothing at all. That looks like a washer.
A beautiful view of Atlantis from Dan Burbank's perspective, looking back at the station from the outermost point of the port truss.
Okay, Dan, we got a few pictures of you, and mine says to go back to work.
Okay. All right, first thing is to retrieve my tethers, and then I'll be off the launch restraints, I believe. Yeah, see how a 2-inch wouldn't get us in there.
No, I know. If we had... This is the free one.
Yeah, I can see the 2 halves are moving relative to the fitting.
You see now it's moving even more?
Right, now what about that upper one, or that outer one? So the inner one is definitely loose.
Yes, it is. Oh, there it goes. Okay, I got an 1/8 of a turn. I don't know if we just muscle that. I'm a little afraid of galling the whole thing and making it tougher.
Well, we don't have much choice.
Yeah,
if you break it, mission accomplished. Okay. And then when you got it. Get a good full throw on it. Okay, nice. You got it? Yeah, here we go. Okay, do it again.
Looks like it's going pretty easy now.
Looks like it's coming a lot easier, guys.
Apparently Dan has a magic hand.
Flight DBA.
Go.
How many astronauts does it take to turn a bolt?
1, 2.
Okay, just got it. Okay, how many threads we got exposed there? There's them more than cable pulls with you there, Joe.
Yeah, buddy.
Yeah, 6. Okay, well. All right. We'll get it. We'll get her yet. All right. I got the match. Oh, yeah, we're doing good. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, probably 13 threads exposed. And you can see the shiny ones there where it's gold. Yeah. The ones that are just coming out now. So that's why it's getting easier, because the stuff that's really tearing up, those threads are starting to come free, and there's less of them.
Hey, you're probably just cutting a new set of threads.
Probably. I think so. But we don't have as deep, there's not as much that's actually engaged. So it's getting easier. Well, let's go. Okay. Back at it. Let's look at it. We got the shiny golly ones, 1, 2, 3, 4, 5. We had 2 a couple of turns ago. Okay. Oh man, that thing is up there. Oh. We're just tripping it like you wouldn't believe. All right, well. The bolt's going to be a few thou smaller in diameter. Yeah. All right. Here you go. Okay, there we go. There we go. It's starting to get nice and easy. Yeah. Okay, I think it's PGT territory. So whatever's left, we can go up to the other. Sure. Think so? Yeah, well, I don't know. It seems, not much. Real, there's hardly any torque. Is it still? Yeah. No, it's turning almost free. Oh, it's good. I think we're good with that. Why don't you try with your PGT? Yeah, let's. Get in there, it's better if I try. I think it's harvest time. Woohoo! All right.
That must mean it's driving.
With the torque is. Okay, that one's free.
Now there's much rejoicing.
Yeah, that was
Can you see the torque?
Yeah, 1.5.
It's just a running.
Yeah.
You guys didn't spend enough time at the gym.
Well, yeah, Steve broke one of your tools already because he didn't spend enough time at the gym.
I know, they're going to take it out of my wages,
Yeah. Spent too much time at the gym. All right. Good deal.
Oh, wow. Okay.
Not much left of that.
Yeah, that's pretty interesting.
And Atlantis, Houston for EVA.
Go ahead, Pamela.
Yeah, we have wonderful views thanks to Dan's helmet camera. And we sure appreciate you answering that age-old question for MCC. How many astronauts does it take to unscrew a bolt? And apparently it takes 3, 2 outside and 1 inside. But seriously, you guys did an awesome job, and that was great teamwork.
But it wasn't a light bulb, Pam.
I tell you, this was an amazing effort, you guys. You wouldn't imagine the drama inside here, and I'm sure the drama on the ground right now, or a few minutes ago.
Yeah, that'd be a showstopper for rotation and deploy.
You betcha.
Okay,
Okay, so I'll give you your PGP. That's actually yours.
This is Mission Control Houston with a view from astronaut Steve McLean's helmet camera as he and astronaut Dan Burbank move on to one of the get-ahead tasks from previously scheduled on EVA-3 to remove the keel
Drop off the ratchet and the rigid.
beam here, seen
Sounds like a plan.
with McLean's left hand near it, the triangular-shaped beam that was in place for launch but will be stowed inside the truss, so this railway will be clear for the mobile transporter to run along.
And no gravity, I'm not sure. That
I don't think
gold mine just stay in there all by itself without doing any turns.
I totally agree. Okay. I don't think it's there. Okay, this is good. It's in. All right, very good. Okay. All right. I got it. Okay, it's all yours. Okay. I'll rotate this way.
Okay, Dan, you need to work it all the way in until you're just holding the clevis bolt end. Steve, you transfer from over that beam, your right hand is on to under, just like you're doing.
Okay.
Very nice, gentlemen.
Okay, and let me pull it up so you can reach it. Okay, and then we're going to go for the rig.
This is Mission Control Houston, the Falcon flight controller, the power heating, articulation, lighting, and control officer in the space station flight control room reporting that the SARJ, or the Solar Alpha Rotary Joint, is in movement. Here you can see it rotating as part of the checkout of the joint and to position it correctly for the deployment of its radiator on the P4 truss.
And the port solar array wing mast deploying. That deploy coming at initial start of deploy coming at 4 a.m. Central Time, and this will deploy only one bay initially to evaluate the mechanical process.
Atlantis Station, Houston, you have a go to pick up in step 15.7 for the SAW deploy.
Atlantis copies.
And that call indicating that the space station is now in free drift, meaning all of the attitude maneuvers are inhibited. The crew's been given a go to deploy the first of the two solar arrays. The International Space Station beginning to spread its wings with the first of the two new solar arrays now in the process of being deployed. Each solar wing measures 38 feet wide and 107 feet long. Each blanket has 84 panels, and of which 82 are populated with solar cells. Each one of the panels contains 200 solar cells. And in the far distance, beyond the solar array, the early blue color of a orbital sunrise approaching.
Atlantis Station, Houston, on the big loop. Station is in free drift. You have a go to pick up in 15.7.
Space station is back in free drift, inhibiting any attitude maneuvers. And the crew has been given a go to resume the deploy of the port solar array. And at 7:03 a.m. Central Time, the deployment of the second array resumes. The darker areas of the array are representative of the stiction phenomenon, thus the reason for stopping halfway or at about the 49% deploy point. That is the stopping point where the teams will allow the thermal conditioning to begin. That's about a 30-minute or so clock that will allow the warming of the solar arrays before the continuation of the deployment. While the arrays are obviously identical, the one difference is this array actually was packaged much sooner than the other array, so but the deploy sequence is continuing identically to that of the other array.
Houston, good deploy 15.5, GMT 12:08.
Copy and concur. We confirm nominal deploy to 49%. Station Atlantis, Houston, you have a go for orbiter free drift, and then a go for solar array deploy.
And the orbiter is in free drift. 2B deploy is underway. 2A deploy is underway.
And deployment of the second solar array resumes.
Daylight. Daylight.
This is Mission Control Houston. The hatch cover is now open in preparation for the opening of the inner hatch. That hatch now coming open.
Houston, step 15, we can verify the emergency MPEV is closed.
Okay, since I see daylight, I'm putting my visor down. Okay, I look in a good config. I'm egressing the airlock.
Okay, Heidi, and I concur. We've got a great view of you, both from the C camera, and WVS is solid on both.
And I can verify both your safer handles are good.
Okay.
Ramp is released.
And then re-engage the capture plate and start equipment.
I'll do that just because you said so. Oh, I got to pull them out again first. There it is. That's engaged. All right, now.
Okay, I got my BRT rigidized.
Okay.
I want to take this.
I need to mess with the joints too. Ramp is released.
And then re-engage the capture plate and start equipment.
I'll do that just because you said so. Oh, I got to pull them out again first. There it is. That's engaged. All right, now.
Okay, I got my BRT rigidized.
Okay.
I want to take this.
I need to mess with the joints too. Right there. Okay.
Just go real slow. If you get another turn on that rigidization, that would be good. It's not holding very well.
Did I miss it itself?
On the BSC.
On the BSS, I mean.
Yeah, give it
a... Heidi Piper delivering the materials for ISS experiment back to the Quest airlock. That will be returned home for evaluation by experimenters on the ground. That exposure experiment has been on the station for quite a while.
I can wave a lot. Eight turns. That one broke at 11.
Sure, I'm glad we bought all that heavy hardware, because if we hadn't, we would have needed it.
Yep.
Heidi Piper using her pistol grip tool, her power socket wrench, basically to release some winches and locking bolts on the photovoltaic radiator, the PV radiator that will be deployed a little bit later. This accordion shaped radiator will be deployed to provide cooling to the newly installed P4 truss and its pair of solar arrays that were deployed on Thursday.
Well, that's a pretty above average view I got right now. Okay, Heidi, you have it, and I'm going to untether.
I have it. I'm tethered to it.
And I'm untethered.
Okay. Gonna lean back and I'll clear you.
Okay. I'm out of the APFR. APFR is empty.
Joe Tanner moving out of his foot restraint and thus clearing the way for the deployment of the new radiator on the P4 truss element.
Houston, Atlantis for EVA. This is a good time to deploy the radiator, and we'll wait for you.
But there's the Suez Canal.
Yeah, I know.
Wow. Holy Land. You guys look out W1.
Yeah.
Wow.
8:05 a.m. The radiator is in the process of being deployed.
Atlantis Station, Houston on the big loop. The deploy has started.
And we're watching it, Ben.
Yep. Like a deploy. All nominal now, Houston.
And Houston, Atlantis, we're watching the gimbal being commanded as well.
Looks pretty close, getting closer to 100% here. Compared to one of these other guys.
Engineers here in Mission Control confirming that that is a good connection of the main bolt connecting the new S-band antenna subassembly onto the starboard one truss. Crew will continue mating the electrical connections to that hardware now. This is Mission Control Houston, now 4 hours and 32 minutes into today's spacewalk. The new S-band antenna subassembly now installed on the starboard one truss segment. The crew just completing capping off the electrical connections on the hardware that was just removed, and that will be stowed on the Z1 truss by the crew members for it to be brought inside the station and returned to Earth later. This is Mission Control Houston, now 5 hours and 28.5 minutes into today's spacewalk with astronaut Joe Tanner installing a heat shield on the antenna group interface tube on the KU band antenna outside the space station to prevent that area of the antenna from overheating during different or specific space station attitudes. At the same time, astronaut Heidi Piper working on the starboard 1 truss segment to replace hardware for the S-band communication system, having removed the baseband signal processor from the string 1 of the comm system, and is installing the new BSP, as it's called.
Roger that.
She will also work on removing and replacing a transponder for that system on the starboard 1 truss.
Houston Station on the big loop.
Go ahead, Brent.
Houston, the logbook has been completed. All the ceremonies have taken place, and the STS-115 crew is egressing the station for the final time.
We copy, and we appreciate you keeping up a wonderful tradition.
The crew of Atlantis bidding farewell to the Expedition 13 crew, completing 6 days of docked operations with the complex. Leaving the station a much larger complex than it was before Atlantis arrived on September 11th.
STS-115, the crew of Atlantis departing.
And Atlantis' crew leaves the Expedition 13 crew on its own, but only for a couple of days, as the Expedition 14 crew is scheduled to arrive at the station in the early morning hours of September 20th, following its launch from the Baikonur Cosmodrome on the late evening of the 17th, early morning on the 18th Baikonur time. And the hatch between the Space Shuttle Atlantis and the International Space Station's docking port is going closed. That hatch being closed at 5:27 a.m. Sunday U.S. Central Time. The hatch between Atlantis and the International Space Station was opened for a total of 5 days, 21 hours, and 57 minutes, dating back to September 11th, when the hatch was opened at 7:30 in the morning.
The MAX officer here in the shuttle flight control room confirms that the hooks are open. At 7:49 and 57 seconds. Undocking of Atlantis right on time from the International Space Station.
station Atlantis on the big loop. We're starting to fly around.
Atlantis now almost 500 feet away from the International Space Station with the new solar array in view, the P3, P4 truss structure on the right of the screen, with a new set of solar array wings to almost double the power generation capability of the International Space Station. That whole element installed by the Space Shuttle Atlantis and Space Station crews. With the Space Shuttle Atlantis at least 400 feet away from the space station now, the Falcon, or the Power Heating, Articulation, and Lighting Control Officer in the space station flight control room will unfeather the P6 solar arrays so that they can automatically track the sunlight. Those were feathered in a protective configuration of the arrays during Atlantis' separation and use of the thrusters or steering jets within close proximity of the arrays. This is Mission Control Houston, now 31 minutes after the Space Shuttle Atlantis undocked from the International Space Station. The orbiter at a distance of about 600 feet from the complex as it continues a full fly around of the International Space Station. Now moving up above the vehicle. This is Mission Control Houston. Continue to watch video from the Space Shuttle Atlantis, which is about 600 feet away from the International Space Station as they orbit about 200 and statute miles above the United States. This is Mission Control Houston. Continuing to watch this view of the International Space Station now 40 minutes after the undocking of Atlantis from the complex as the orbiter moves towards the aft side of the space station, looking at the Russian segment of the complex. The new P4 solar array wings extending over to the right on the port outboard side of the integrated truss structure, which is now 179 feet long, with this new P3 and P4 elements. Atlantis now flying around the aft side of the space station or back of the International Space Station, looking straight on at the Russian segment with the Zarya module in the center. Zarya standing, meaning sunrise in Russian. The Zvezda service module and living quarters for the space station residents, Zvezda meaning star in Russian, closest to the end of the space station, with the 21 Progress cargo vehicle still docked at the aft end of the complex. With the hatch closed on that vehicle and it filled with trash, it will be commanded to undock from the space station to be sent to burn up in the Earth's atmosphere. That aft port will be cleared for the arrival of the Expedition 14 crew and a new Soyuz spacecraft. That crew is scheduled to launch from the Baikonur Cosmodrome in Kazakhstan tonight at 11:09 p.m. Central, 12:09 a.m. Eastern on Monday. Additional so-called NC burns are scheduled or planned, one today and two tomorrow, to continue to refine Atlantis's path away from the International Space Station. The NC7 burn late in the crew day tomorrow, set to put Atlantis in a station keeping position about 70 nautical miles behind the station.
Go ahead.
Yeah, for the checklist, we're going to go back and work block 9A and put the radar back on the target.
Copy that.
The crew is still about an hour ahead of the timeline, having gotten an early start on the scanning today and continuing to march through smartly as Chris Ferguson, the pilot, and mission specialist Dan Burbank and Steve McLean have been focusing on these inspections using the robotic arm and their orbiter boom sensor system. The rest of the crew, Commander Brent Jett and mission specialist Joe Tanner and Heidi Steffenich Piper, have been working on early cabin stowage, getting the space shuttle picked up and everything stowed away as the crew gets ready to make final preparations for deorbit and reentry.
Copy, go for AP1 start.
And spacecraft communicator Tony Antonelli giving Chris Ferguson aboard Atlantis the go to start Auxiliary Power Unit 1 in support of this flight control system checkout as we watch a television picture of the starboard or right wing of Atlantis in the area of the aerodynamic control surfaces that will be cycled using hydraulic pressure generated by that auxiliary power unit. And we can see the flight control surfaces cycling through their full range of motion now. And now we're receiving some in-cabin video from the forward flight deck. Commander Brett Jett and pilot Chris Ferguson continue to go over pre-landing preparations with flight engineer Dan Burbank, who's seated directly behind them. They've completed a successful checkout of the flight control surfaces of Atlantis. Everything looked nominal to entry flight director Steve Stitch here on the ground, as well as the data processing system, guidance navigation systems, and mechanical systems officer, all of whom followed the progress of that flight control system checkout carefully. This is Mission Control Houston. We're back to seeing some of the videotape being replayed from on board the International Space Station. This will look as the Progress spacecraft that had been docked to the aft port of the Zvezda service module begins to re-enter the Earth's atmosphere. That Progress spacecraft will for the most part burn up during re-entry, and what's left will splash into the Pacific Ocean. Undocking occurred about 7:30 p.m. yesterday from the International Space Station. The undocking freed up the aft docking port for the arrival of the Expedition 14 crew aboard their Soyuz Vostok spacecraft. That docking scheduled to occur at 12:24 a.m. Central Time Wednesday morning.
This was recorded about 1:45 a.m. Central Time this morning. The object visible to the left center of this view as the INCO officer worked on keeping the object in view. This recording just around 1:45 a.m. Central Time this morning. The crew on board Atlantis had just completed testing the reaction control system or jets on the orbiter. which was scheduled at 1:30 a.m. Central Time. This is Mission Control Houston. Continue to watch video recorded earlier from the Space Shuttle Atlantis about 1:45 a.m. Central Time, as the camera in the payload bay was trained on an object noticed by the instrumentation and communications officer who commands those cameras' movement.
Atlantis Houston was the big picture. The MMT just met, and they've decided that based on this weather we've been having down in Florida and combination with this object that we saw tomorrow, that we're going to wave off tomorrow. So our next deorbit opportunity is going to be on flight day 13. So tomorrow will be a wave off day. We have our FAO and our timeliners are working very hard right now to come up with a plan for tomorrow, and we'll certainly get you any words that we have on that as soon as we can.
Yeah, of course, our big interest is whether or not we're going to be doing any robotics tomorrow.
And that is a possibility. We've got the flight controllers on console now, and we're working the plan, and that's our question too. So we'll definitely keep you in the loop on that as soon as we hear something.
Atlantis Houston for PDRS.
Go ahead, Megan.
Atlantis, first of all, fantastic job on executing the inspection procedure this morning. We're looking at the data just as fast as we can get it downlinked, and the team is meeting to determine if further OBSS inspection is required. In the meantime, we are uplinking message 135, which is that OBSS procedure for you to review in case we do decide to do it. In addition, we have uplinked new DUG targets, and you would need to obviously restart DUG to access those. The procedure has been PV'd on the ground and in the dome by teams down here, and we should know probably in about 40 minutes or so, we should have a recommendation for whether or not we're going to continue and do the OBSS inspection. So we recommend you guys enjoy your lunch period.
This video was recorded almost exactly an hour ago as Atlantis's crew, in particular ARM operators Chris Ferguson, Dan Burbank, and Steve McLean, prepared to begin movement and take an oblique view look at the underside of the shuttle, very carefully looking at all the tiles underneath Atlantis to make sure nothing looked out of place. In particular, they were focusing on areas around the external tank umbilical doors, where earlier in the mission had seen some evidence that some shim stock had been protruding from those doors. The launch preparation team at Kennedy Space Center had removed all those shims as part of a requirement by the Space Shuttle program. However, that requirement came about at a time when the external tank doors were in an open position, and so those were the one area where the team in Florida could not get to the shim stock and remove it. After the shuttle got on orbit, imagery specialists, in doing their initial inspections on flight day 2, saw some of this shim stock. It's a very thin plastic material and would melt at fairly low temperatures, so it was deemed to be no consequence to re-entry and landing, as it would have vaporized very early in the entry profile of Atlantis. However, that is one of the candidates that mission managers were looking at as the potential for the unidentified object that was found to be co-orbiting with the shuttle yesterday during some Earth observations camera photography using the payload bay cameras of Atlantis. Here's a look at some of the umbilical doors on the underside of Atlantis.
And we have some news for you. If it makes you feel any better, both of your deorbit opportunities today would have been no-go. Ceiling is 600 feet at Patrick right now.
Let's hope it gets better by tomorrow. You know, we're just pretty optimistic about getting into Kennedy either tomorrow or the next day. So, you know, that's encouraging. And, today was a long day, especially for Fergie and Dan, but, you do what you need to do, and we hope you guys got the data that you're looking for.
We did get all that data, and we really appreciate it. I know, like I said, they made something very difficult look easy, but MMT is meeting right now as we speak, and they're going over the video that you guys sent down, so we appreciate it.
Hey, whatever, we understand, and everybody's trying to do the right thing, so we're happy to do what it takes.
Sounds good. We appreciate it.
And here will be our commander, Brent Jett, to say a few words.
Good morning. It's really a beautiful day in Florida. Great way to end the mission. I'm not really sure what you say after a flight like that. It was a pretty tough few days for us. A lot of hard work, a great team effort to get the station assembly off, restarted on a good note. We got a lot more missions coming up, and they're going to be just as difficult. I would like to say to the folks here at KSC, though, that Atlantis was a terrific ship. In fact, she gave us absolutely, for us, she gave us absolutely no problems at all over the entire mission. We wouldn't have had time to deal with any of them, so it was real critical that she perform well, and she did. So a special thanks to all the folks here for preparing Atlantis for launch, and the condition she's in now is a real testament to the work you put in beforehand. It was a pleasure to fly her, and it's great to be home. Thank you very much.